So the other day, okay, folks, let's pay attention here now. So the other day, what we did is we started off this class of called employee, okay, and we created one method, right? And this parameter here refers to if the method is going to have a return value. If it's void, it means it's just going to run some code, doesn't return anything. Okay, in this case here, it's going to return to us a double. Okay, so it's going to do some sort of calculation and then return some numerical value of a double. We have two inputs, hours and pay rate. This hours and this pay rate, because they're primitive data types, they have copies. There's a copy that gets created in memory, and it actually gets stored on the stack of memory. Okay, all objects, objects such as arrays, kind of going back to what we talked about earlier in the year, arrays and classes, they get stored on the heap. Okay? So primitive data types get stored on stacks. Okay? Things like this return will also be stored on the stack, something like that. Okay? So in this particular case here, it makes copies of hour and pay rate, does the calculation inside, returns the value. Okay, so that this way when we use it in another class, this method, we can get access to the results that get generated from this. Okay? So, and that's what we did. We went to our user interface, and we just added a button in there. And when we said OK, because this is an object, we have to use the new keyword in order to create the actual object called Ivan. In this case, we use Ivan's name. So Ivan is an employee, which is that class. When I write the code and once I use the new keyword, Ivan is, well, you call it a variable, but they call it an object because it's a variable that we create of a class type that we created. Or even if we use the Microsoft libraries, right, that have all different types of classes. Okay. When we use the graphics object and things like that, remember we had to use the pen last year? We used the pen? Yeah, so the pen is pen object, right? And we use the new keyword. So some of them don't require us to use the keyword, like math console, but other types of classes do. There are reasons for it. I don't want to say it right now because I just don't want to confuse you with it, but we will look at it. So we added in just inside to test out our class to see if it works. We created a variable. We created an hours and a pay rate variable to store in those particular values. And then we created a variable to store what gets output from that particular method called pay. So you can think of that return as kind of being the output of that method, right? So when we use pay, we have it. We write that double for that with that return. That's kind of like the output of it in a way. So when you're looking at methods, you can still look at input, process, and output. Input are your parameters that you have, 0 or as many as you need. Your processing is what goes on inside the code. And then if you're going to output something, you have the return value using the return. And then that gets output. So person accessing that method. So you kind of have all those input, process, output in there. And then you use variables for the storage, right? So all those components are used. So like I said, everything that you do, and when you kind of get confused on things and what's going on, you can always go back to that input, process, output on storage. And kind of help yourself understand what's going on, and maybe that'll help you. I know it used to help me when I used to do things like that, and I had trouble understanding things. So, and once we get this pay, it comes from inside there, we can output it or do whatever we want with it. It's separate from that method. That method is done. It gets bumped off the stack and it's gone, and we get to go ahead and do whatever we want with the output that is generated from that method. Okay, I just want to make sure that everyone's okay with everything that we did up to this point. Is it good with everybody? Does everyone understand? Are the methods kind of make more sense now how they work? Yes? Yes or yes?
Understand it, but then yet might not understand if they introduce new things.
Okay. What I'm going to show you is something new, and it's going to be called a constructor. So when we create a class, there's a special kind of method. It's not really a method, but it kind of is. That's called a constructor that we use. And this particular method has the same name as the actual method, the class itself. So you create this constructor by using the name that is of the class. Has to have the same name, and it can have as many outputs, but it can never have an output. Okay, did I just say output twice? Yeah, sorry. It can have as many inputs as necessary. That's what I meant to say, but it has no outputs. So like this. So we'll go into our employee class. Now, to do a constructor, I usually put it up at the top. So I'll do my little line here. It's just a kind of a nice way to organize your code. You don't have to put the lines in, but it's good to put the comments in for each of your section. So this is where all my methods are, right? And we'll put other ones in there later. But over here, I'm going to put constructors, constructor. Okay? And the way you set up a constructor is I would put public. Okay? And you don't put any return data type. Right? So no void and no data type. There is none. And then you just put in the name of the class, employee. Okay? And then this. And then your inputs. What we're going to do is that when we initialize this particular employee, we're going to set their pay rate. So whenever I create, in this case, Ivan's employee, his pay rate is going to be generated. It has to be set when I create it. When I use the new keyword, Ivan, I have to put in your pay rate. Okay? So probably I'm going to read that in from somewhere, like a database. So a lot of times what the constructors do is they provide initialization for your class. So when your class is going to be created with the new keyword, it goes into the constructor that matches it, okay? And then it runs the code that's in there. So let's say I have to connect and get the information from a database. Okay, does everyone know what a database kind of is? Sort of. It's data that's stored inside some sort of program, and we can actually program it, right? And all the data is inside there, and we can use any programming language to connect to a database and extract information from it. So let's say my database might contain all my customers that I have, right? Or maybe it contains the list of all my employees. And then maybe it has a list of all the employees that have made sales over the last month. All the sales information goes in there. It ties into who did it, right? So you can create these databases that store all the information about all the interactions that go on within a company or whatnot. Okay? It's kind of like, instead of using a file, like I can have files for all those and you open it up as a file. So right now, I mean, I'm not going to teach you what databases are and how to do that. You'll probably learn it in university and how to code them properly and everything. But think of a database as kind of like a file with information in it, and then you're extracting it. Is that kind of okay? Think of it that way? So I might use file, but out of habit, I might say database. All I really mean is like a file that has data in it. Okay? So let's say I wanted to load up this employee. What I might even put here is a path to where the file is, or the database. And what will happen is that when I use the new keyword, it'll go in there and it'll get all the information for this particular person. Or maybe I put his employee number in there. I ask for employee number. So when I create the actual person, I input their employee ID, and then inside the constructor, it makes a connection to the database and gets all the information I need to about that particular person based on that ID. And then I can store it inside the class, and then access the class and give me information. Okay. Another way might be, in this case here, when I create it, maybe what I'm going to do is I'm going to store his pay information. We're going to kind of manually do that. So what we're going to do is when I create a constructor, I'm gonna and we can have as many inputs as we want, just like any method. So we're gonna put a double in here, and then we're gonna call it pay. What did we call it before? Pay rate, and we'll put that in there. Okay, that's gonna get passed in. What I need to do is have a mechanism to save that. So while my class, so when I create a class like over here inside this form, so when I create a class inside this form right here, I have this variable Ivan. While Ivan is alive in the code, right? Because I created it inside this button OK. Once this button OK ends, that object is deleted from memory, right? Okay. So C#, the garbage collector in C# will say, oh, it's not being accessed anywhere, and then it will become available to be rewritten over in memory. Okay? So while this is open, now any variables or anything inside this employee class will stay alive. Think of it in that manner. While this Ivan is alive inside this code, until I close them down or until this method ends. You see, it's not global, right? If I make it global, then you'll be alive for much longer. Okay? You make it go away. Okay? So what I can do inside this employee class is what I want to do is I want to create a private variable that's global that I could use inside any method, inside anywhere, and access it that'll actually store what this pay rate is. Kind of make sense? So what I'm going to do at the top here is put another little section in here. And we're going to call it fields. Another name is data members. Okay, these are typically variables that are global within your class. Everyone understands when I say global, I can access it anywhere, right? Okay. That are global within the class. Okay. But I'm going to make them private so that somebody that uses my class can access them directly. They're protected in a way. Okay? I'm starting to get into concepts of object-oriented programming here. So what we're getting into is what's called encapsulation and data abstraction. So what I'm doing by creating a private member, so I'm going to create something here called private, and then I'm going to double, and then I'm going to call it pay rate. Well, what I'm going to do is I usually put a little m in front of it, because that means it's a private member. It's a member variable that is global within, and you use it. So we usually don't do that kind of thing, but I usually do it in classes. So now I can use, I don't get mixed up when I pass in the same names, or you start to get confused on, and you have to come up with different names for everything, and it makes it even worse. So usually I do this. So I'll create private, double, and I'll do m pay rate. Or sometimes people just do it all in lowercase. So what I'm doing is I'm encapsulating here. I'm creating, I always get mixed up between the two, data abstraction and encapsulation. The two terms are very close. So what we want to do is we're going to hide this variable from direct access, and the only way you can access it is either through a method or a constructor or through a property. You can't go directly and access it. And the reason we do that is we can protect that variable from improper use. We can protect that variable, and we can even put restrictions on it. Let's say I want someone to put an age in there, and maybe I have an age property. Obviously, a person can't have an age that's less than 0, right? So I could put an actual when I create the property, I can put code in there, and we haven't done this yet. but what properties are. But if you want to assign the person's age, I could put a little check in there to make sure that they are greater than 0. If not, the coder that's using it will get an error, or the program is going to generate some sort of error. Okay. So with data encapsulation, you're encapsulating, you're creating these variables that store data that's related to the class, but you're not directly exposing them. You're going to expose them through a method or a property. And the method or the property is the abstract layer that kind of hides that variable. Okay? So we'll just kind of call it all encapsulation. Kind of leave that data abstraction out there so you don't get confused. But really, when we create a method, or it's more when we do a property, we're hiding how we assign values to variables, or even to get access. So I'm not going to directly get access to this variable that's inside here. I can only get access through a method or a constructor, right? Or a property. Okay? You'll see that as we go along a little bit more. Okay? So that's your first rule of object-oriented programming. It's called encapsulation data abstraction. So what we're going to do here is that when the person constructs their class, they're going to pass in the pay rate, and the pay rate's going to get assigned. And we want to M pay rate, it's going to equal pay rate. And then that's it. It's done. Now, guess what? I could use pay rate in any method, right? I could use it in my class anywhere. Do I need to ask for it over here? Nah, I already have it. Because when the person uses a new keyword, they have to pass. So we could delete it from here. And what do we put in here instead of, if I'm not passing, I already have it stored. And it's stored as what? What's the pay rate stored as? What variable do I use? M pay rate. Okay? So you're going to do M pay rate. And it's good to have the M in there because now you know that you're using an encapsulated variable, right, that is hidden from the user, but it's been assigned a value. Okay? So when I access this pay method, I just pass in the hours, but it's going to use the pay rate that gets passed in when the person is created. I know it's a very, very different way of programming, very new for what you've seen, but it'll take a little bit to understand. But just like the 2D arrays and everything, you got to work at it, and then once you get it, it's not that hard anymore. Okay? Because it's just new, the concepts. I want to make, does everyone follow so far? So we got it. So I'll show you right now. So let's go to our form. Let's go back here. We're going to have errors. Because obviously, when we call Ivan.pay, we don't need to pass in the pay rate anymore. So we're going to get rid of that. We're going to move this variable up over here because we need it before. Okay? So when we calculate the pay, we just pass in the hours. Now the pay rate gets passed where? How does the pay rate get passed into this person? Where did I show you? Where does it get assigned? In that what? Did you guys say over there? Sorry, I can't hear you. The constructor. So now, check it out. When we say new employee, and then you put the bracket, notice that it comes up double pay rate. We have to pass in the pay rate. So we'll put the pay rate in. Okay? So what's going to happen here is when Ivan gets created, he is assigned, his pay rate is $11.50. So later on, when I use the method Ivan.pay, we pass in the hours, but it uses that pay rate because that pay rate's already stored in the class over here. So I don't need to ask it again. And then there you go. Hours is here, hours times the pay rate, and then you're still going to get the same answer. But what I'm doing here is I'm forcing this, and it depends how you design your classes. What I'm doing is I'm forcing this person to, you have to create, when you create this person, you have to tell me certain things of it, certain aspects of information, okay? Certain types of information, and I want it to be set when the person gets created, or the new keyword gets set up. Okay, so you guys will go to your lunch, and we'll continue from here when you get back. Okay, so is there any questions on kind of what we did? Okay. So that's what a constructor is. You know what a method is. I haven't shown you yet what a property is. Some languages don't use properties like the way Microsoft tools do. We could easily write a little method that says get pay rate and set pay rate, right? If I had a little method, and then that little method would expose to the person the access to that private variable, which we named as m pay rate. So if I do get pay rate, all I would do is just return what the m pay rate is, which gets, right? So that's what you, and the person would be able to get that value. If I call set pay rate, then you would have to have an input into that particular method, and then that would go ahead and set the m pay rate value, and then while that particular object is alive, then it would you would have access to it, and that's another example of encapsulation. Now we could do it in terms of methods in that particular way to get access to these private variables. So that's one way of doing it, and I think Java you have to do it that way unless they've changed it since the last time I used it. It's been a while since I used Java. Or we're going to use. I'm going to show you how Microsoft. They have an actual special keyword called property. And this way you assign and access a property using an equal sign, as opposed to a method where you pass inputs in through, right, the input parameters and use the return value as getting a value back. So this is two different techniques. I kind of like the property way of doing it because, I don't know, it's like an attribute of something. It's like a different way of accessing. But it doesn't really matter. In the end, you're still using the same concepts of encapsulation and data abstraction, whether you make your own method to kind of be like the little shell around it, it's like your little protective shell of that variable. You can't get at it unless you either use that method or you use that property. And that's a very nice way of protecting the data that you have within each of the classes. Before I go on to show you how we would design a particular class using a what's called UML, what we're going to just take a quick look at is in the notes. I just wanted to illustrate to you that you can pass an array into a particular method. So at times maybe your array is not global, or for whatever reason you might be, whatever's going on in your code, whatever the situation is that you may have an array. So when you actually create your method, okay, you put the variable in as it's an array, but you never specify the size of it. Okay, so let's say I wanted to pass in an array of my marks. So I would just say these marks are an array of integers. So you just write int. You put the square bracket there. Square bracket. If it's a two-dimensional array, you put the square bracket with a comma. Right? It just says it's a 2D array, and then just put the whatever name that you want to give it. That name does not have to match the name of the actual array that gets passed in, right? It doesn't matter. And then and then when you use it, you just actually write the variable name. So here, this method is called showMarks, and it requires an array to come in. And then when I call showMarks, I just put the variable name in of the actual array. And what it does is it passes in by reference. So if I bring this marks array inside here, it's actually pointing to where the original array is. So if I change any of the values and any of the elements of the array, unlike the primitive data types which make a copy, arrays do not. Remember, you can't make a copy in memory. Like the computer or your language will never make a copy of something like an object or an array. You have to physically do those, right? Because they're in actually another part of the they're on the heap part of the memory. Okay, so if I pass in an array and I change a value inside there, once that method is done, that array has that changed value in it, right? So I think later on we'll use it. We'll use the array later on. I think when we're doing something like we're going to do like a little grid on the screen. So a grid is like an array of cells. So I don't want to get into too much detail with that quite yet, but we'll do that. But that's how you access in the notes. It's called arrays and methods. So you can take a quick look on that. But we will go into a little bit more detail. So for now, just keep it in the back of your mind. Just remember, primitive data types coming into a method, values or copies, doesn't matter. Arrays or any other object, I could pass in an employee into a method. That's passing in the reference. I change a property or something inside there, it's gonna change the original, because it is the original. It's pointing to the same location of memory. These are the things that if you cannot get straightened out this year, next year, for all the stuff that you're going to do, you're doing advanced data structures, and you're manipulating all these pointers, right? You gotta. That's why I try to teach you to think in these terms. So yeah, it's a little bit harder now, but when you get to it next year, you'll know what the teacher's talking about, and then you'll focus on the deeper concepts out there, where other students might be still struggling with what's going on here. And they might be coding and it works, but then in the end they don't really understand, then they can't, then they get really messed up. Why? Because I know I was there. I got messed up with some of these things initially, right? So I don't want that to happen to you guys. So it's understanding how it works in memory is key. So when we're going to design, when we're thinking of doing the design part of our code, before you even write the code of a particular class, you shouldn't just pop up your computer and just start adding things in there, because your class might have to interact with other classes and other things, and unless you start to write things down and start to design the classes. So I might design the class and then I start to put everything in. I didn't code it yet. Okay, that's fine. Then I start designing a couple of the other classes, and then I start to realize that, oh, wait a second, in order for this one to talk to this one, maybe I got to tweak this. And then you start to, and you didn't code anything yet. You start pen and paper, you start to move things around, and you start to make adjustments. And then you're like, now it should all work together properly. Okay? And when you do it that way, it really simplifies things. It makes things flow easier. Because if you started to code, what will happen is in the end, you're going to have to scrap. You might have to scrap a whole bunch of things, a whole bunch of code that you did, and you're like, oh, this stuff's not working now. I never thought of that. Yeah, but if you did the design, you would have thought about it, and then you would have been able to come up with a solution. Now, the way a class diagram kind of looks, this is really the official way of looking. So you kind of make a little table chart. Let's say you would do it in Word, let's say. And then you put the title up at the top of or the name of the class. It goes right here. And then the very first, these are off. It should be pointing up here. So like I said, I had moved things around with these notes. So this is the class name, and it should be right up here like this. Let me see if I can move it. Okay, like that. So that top's the class name. Let me just move this up a little bit better. I didn't realize that this had moved. Okay, that should be good. Over here, then you break your table kind of into three sections. This section, this section, this section. So this over here is the fields, is the first section. Typically what you would write down is how you would declare it. Now, this first line right here is kind of like the true UML way of doing it. You would write whether the variable is private or public. So for our fields, typically they're going to be private. You write private, and then you give the name of the actual variable. UML uses a semicolon and then puts the actual data type after the semicolon, or colon, sorry. I say, guys, you just write it the way you would in C#. So you would write private double salary. That's good enough. Okay, so you don't have to do it like this. If you want to, that's great. I say just write private double and then variable name. Don't put a semicolon or anything after it. You just declare, and you're saying whether it's private or public, the data type, and then the actual name of the variable. Sound good? Okay. If you don't want to use private, you could put a little negative sign in front as a shortcut. So the negative symbol in front replaces that, or the dash represents the term private. Okay. If you want it to be public, as you see down here, where this one is, you put a plus there. Okay. But I say just write the whole thing out. So this section here is all the properties. You just put the, whether it's public or private, data type, and then the name of the actual, same thing. Okay? Methods, all you do is you just write down what the methods are, and then you put down everything. Okay? And again, you just put public, and then you can put the data type after it. So we're going to kind of change these. You just write it down how you would declare it in C#. Doesn't make it easier for you. Okay? So it's actually kind of easy to do it that way. I know that I showed the proper way here, but every year I give you the option. You could do it this way, or you would just do it the way you would in C#. But just for one line. You don't put any code in there, nothing. You understand? No code goes in here. Okay, nothing like that. All you do is you just put down like the declaration of each of those. You put down the declaration of the field, which is just a variable. You put down the property, which is technically just a declaration like you would a variable. And over here, you would, for a method, you would write really what that first line would be, right? So in a method, it would technically be, if I go to over here, you would just type this in like that. You see? Just that first line. That's it. Nothing else. No code, no anything else. That's it. Make sense? This way you can see what all the things are, and if they all work, and you're covering everything. Okay? C# has a pretty cool tool. So we could kind of do it in C#. It's called a diagram. You can right-click over here, Employee Manager, do Add. Oh no, so right here, sorry, it's View Class Diagram. So you guys could do it right now if you like. We could click View Class Diagram, and then it'll add a class diagram 1.cd file. And when you open it, up, you'll see it put every single class inside here. It put our settings, which we could, it's over here somewhere, we can get rid of that. It put this program static, it put the program.cs file, it put our form class in there, and it put our employee class, and then it put our resources class. Now some of these we don't really need in our diagram, so I think if we delete, let me do it, though you don't do it, because I don't want it to, if it deletes the file, I could easily fix it. I believe if I just get rid of this, yeah, I don't want to really see those, I don't care about those. But my form class and my employee class probably good. Now, so you guys could delete yours. It didn't delete them. I just wanted to make sure it didn't before you did it. So you could delete all of them except for the employee class, and you can leave this form class off to the side. Now we'll do our design through this thing instead of through Word. Well, you know what? Maybe I'll get you to do it through Word one time, just so you get the hang of it, and then you could use this. But on the test, I'm going to have to ask you. You're going to have to do it by hand and write everything in these spaces, right? So there's no other way around it. If you hit this little these little two arrows on the right-hand side, it'll expand it out. Look at that. It's nice. It puts everything in there for us. So if we look at this, notice where does it put the constructor? What section? Where's my constructor? Fields. Okay? No. My constructor's not on the field. What's the name of my constructor? Pardon? My constructor? Huh? No, that's a private field. Constructor. When I use the new keyword, remember? It's under the methods. And my name of my constructor is, just to make sure you're telling me, huh? Yeah. So employee over here, it's the same name as the class, remember? That's my constructor. Okay? That's my constructor. And employee, and then you have the method called pay, and then there's fields there. I don't have any properties in there yet, because I haven't shown you how to do those yet. So we'll do that. If I want to add an extra method, it's pretty cool because you can do it inside this little tool, and it'll actually create the code for you, which is nice because then if you delete it, it deletes the code for you. When it creates a code, it doesn't actually put everything in there. Like it creates a shell for it, and then you would add it in. So let's say I'm the lead for my project, and I got like 5 or 6 other folks working under me or working with me on the project, and I'm the lead architect. I might want to design how the solution's going to be, so I'll spend a couple weeks maybe doing this, and then once it's done, I'll post up the program so that the more, let's say maybe the other folks working on the project can check out whatever files they need and work on whatever classes they're working on, and the whole shell's in. And then you just put the code in, right? And if there's an issue with something, they might come back to me, let's say, and then we'll work out, oh yeah, I forgot about that, and then we work together to get it all to work out nice. I'll update it, send it to them, they enter the code in. Now that's ideal, it doesn't usually happen. Typically what will happen is the architect kind of, things aren't that complicated, but if it were, we would do it this way. Or if I had really junior people or like some students from, summer school, what do you call it, co-op students, I might start off until I knew what they were capable of, and then I would do it this way. And give it to them, and then they would code it. I'm like, you're pretty good. Next time I say, you try to develop the class. Show me first. They design it, and then they learn, right? That's how it works. So if I wanted to add a new method in here, I could just go inside there. I could click on, let me see. Okay, where's the thing here? Class details down here. There we go. It adds a little tab on the bottom. You see where it says class details? Do you have that show up on the bottom of yours? Yeah. So if you select on what class you're dealing with, if you pull this class details up a bit, I don't have much room here. You see that there's methods, properties, and fields, and even events. We could create events too, but don't touch that stuff. So let's say I wanted to create another method. Notice that it has my employee pay and it says add a method. So let's just say I'm going to make up a method called, guess what? What should I call it? Foo, yeah. We're going to call it Foo, man. Fu Manchu. Foo. The type over here is, well, what's the return type? Like what data is Foo going to return? So let's say I'm going to keep it as void. It's not going to return any value. And then the modifier over here is public or private. Now there's other modifiers in here. I haven't shown those to you yet. So keep it as public. Okay, I haven't talked to you. Summary, I don't know. I think you could put comments in there. And where are my oh, okay. So and that's how that would be the first line. If you open up foo, okay? If you open up foo, you can add your parameters. So foo, we could call it param1, and it's going to be a string. And let's say my second parameter 2 is going to be, I don't know, a double. I'm just making up stuff. We're going to delete this. Okay? So I just created a method called foo. Its return type is void, but it has 2 input parameters, string and double. Okay? And if you set that, it's already saved. Now open up your employee class and let's see if it did anything for us. And check it out. It actually put foo in there. It's void. Param1's a string and param2 is a double. And over here, so if you were to call it, what it'll do is it throws an error. Okay, don't worry what that does. It puts these little default things in there. So if you try to use it, it'll throw this error, and then you'll know that there's no code in there yet. Okay, so it'll run in code, but it doesn't do anything. Usually I just delete that line. Okay, and then I just put comments in there to do. So usually I'll just delete this, and then I just write to do. So then when I want to find all the things I have to do that are still left in my on my list of things to do, I just do a search on my whole class or my whole project, and I'll be like, oh, I forgot about that. I got to do that still, right? So, or I'll be like, oh, I actually did it, but then I forgot to delete to do on there, right? And then you can go ahead and if you run it, it actually works. But it doesn't do anything because we didn't code it. Now, if I go back to my class diagram, I don't have much room here, and I actually delete it, right? So if I could delete it from here. So I'm going to delete the code. Foo goes away, and if I go back into my employee class, it's gone. So you can use that as a kind of nice handy way of designing. Pretty cool, right? So this way you can design in Visual Studio and have your code generated for you too. Saves a lot of time. So what we're going to do tomorrow, just before you go real quick, hold on. I'm going to show you properties real quick. I'll show you enum real quick. And then what you're going to do is I'm going to give you a whole list of things that have to be implemented in this employee. And you got to create the property for them or the method. The enum we'll do together. We'll use gender as an enum. Okay? Yeah, you'll get an assignment, don't worry. Not quite yet though.